So basically the purpose of this lab was to go over the mux and decoder as well as their implementations. And we saw this by using the medium size or medium scale integrated chips. And so basically the first part was basically on the mux. So a mux is basically like, or at least for this one, it's a device where it takes 4 inputs and it spits out 1 output. And there's these select lines that choose which input to be at based on what the inputs are. So basically, and then negates anything else for the other gates too. So for example, if the select lines are both 0, and we choose the first gate D0 to, or the first input D0 to be 0, then that's going to spit an output voltage of 0. And we can select it what we want it to be, high or low, depending on which input we want for each of these. And when it's like this, it doesn't care about the other gates. It just only cares about what that gate is going to be at, depending on like what the options are. And then from the voltage table, I calculated the sum of products for the sum of products, and we use the sum of products later on when it comes to making the actual logic gates, including when we hook them up together. And then we have the voltage table for when we compare to see if the LEDs, when it connects to, are going on or off based on the select lines. So this is just the hand-drawn diagram, and then here's the BDF, and we see that the voltages do correspond to the outputs based on the select lines, and that it is true for when the switch, based on what the select lines are. And switch legend. The decoder. Alright, so the decoder is interesting. It basically just takes us a hexadecimal number to display on a 7 segment display. And this was hard because I didn't realize the A and B were confusing me in the lab document, because I didn't know if they were referring to the display or the actual segment. So like the display letter, so which is with this one right here, which is what the hex display is. And basically I looked at the hexadecimal number and what it would be on the 7 segment, and whatever segment's letter that lit on is what I'd assume to be true, since the doc says that we should assume that all ones are true and active high. So for example, if it's 0, it's gonna have all these outer segments lit, which would be true, and then only the middle segment would be negated or turned off. In this case, we're only looking at A, B, and C, since that's the only one that we needed to find. So it would be A, B, then C. And then we had to do the products of sums again for A and B, and also we did a sum of products for C, just to show that it would still be kind of the same thing. And then we just did the voltage table again. The voltage table does correspond to it. Yep, and that should be it. There was only one thing I didn't know how to do, which was really part C. Part C, I kind of procrastinated since I did most of the lab one day, and I didn't get to finish it when it came times, but this is as far as I got. I just didn't do the Quartus stuff, but I did get the voltage table and the MSOPs through the Carnot maps. But yeah.